the sapphire. Nobody's much. Go.
Evening, ladies and gentlemen. Welcome to the Ontario Science Centre and the Recreational Astronomy Night for the Toronto Centre of the RASC. My name is Tom Luton. I'll be your Master of Ceremonies for the evening. Is there anyone here for the first time? Welcome. So this is one of two types of meetings we have here at the Science Centre. Our Recreational Astronomy Nights are when members of the club will come up and talk about what they have done and where they've been. And we also have speaker nights every 2 weeks, in which twice a month. We have two meetings twice a month, and one of them is a recreational astronomy night. One of them is a speaker's night. Now tonight we have Ed Treijs doing the sky this month, Dan Falk, the footsteps of Nicolaus Copernicus, and Blake Nancarrow using the robotic Burke-Gaffney Observatory. So I'm going to call on Ed Treijs to come start us off.
So hopefully everyone can hear me. So I'm doing the sky this month, but with the month being a little bit asterisk from today through to November the 6th, because November the 7th, I believe we have our next recreational astronomy night, and someone else will be doing it. So the first thing I have to say, and this is a personal experience, so it kind of goes in with the whole what did you experience? I was up at the CAO, and I'd planned that for a long time, took the time off because it's new moon time. And I was out puttering around Monday, which is Thanksgiving Day, in the evening. It was getting dark, and I was setting up my telescope, and I thought, gee, I'm seeing a lot of meteors. Eventually, I pulled out my zero-gravity chair. This is like at 7:45 p.m. It's not even completely dark. And yeah, there are meteors going off like every minute more frequently. And I traced back the radian, and it was somewhere to the north. And I went, that's interesting. I looked in the Observer's Handbook, and they have no meteor showers listed. I thought it was those camelopardalids that we all chased about. Where's Ron? We went and tried to catch the camelopardalids. But as it turns out, they were the draconids, and they had an outburst. But a lot of places, when I went and checked afterwards, they said, we don't really expect very much. They're kind of a boring meteor shower. I don't know what the moral of this story is, other than keep looking up, and the sky this month will never cover everything. They won't really alert you to everything possible, and sometimes things are unexpected. So the more you look up, the more you probably are going to see. So I'm going to take a little bit of a different approach this month, and there's reasons why I'm doing it. And I'm going, what does the sky do in a month in the big picture? So for a month, we have a full cycle of the moon. That's where the word month comes from. So it starts with a new moon, which is very close to the sun on either side. We have first quarter, which will be high in the sky at sunset, and it sets around midnight or in that area, and that kind of moves around a little bit, but in the middle of the night. We have a full moon, which is basically opposite the sun. It rises when the sun sets, and it sets when the sun rises, so it's in the sky all night. And if you want to see something other than the moon, well, you're going to be out of luck. And then the third quarter rises, in the middle of the night, and it's high in the sky when the sun comes up. And one of the frustrations that I have, and I say this to graphic designers or writers of books, the moon doesn't work that way. When they say, oh, the thin crescent moon was rising in the east as the sun set. No. Or you see pictures of a crescent moon with the lit part upwards in the night sky. So where's the sun? Because the sun... Anyway, so this is one of my peeves, and it does throw me out because the moon does definite things, and it affects us pretty much. Where in the cycle... It kind of depends on the sky this month, because we can start in the middle of the cycle, but it always repeats the cycle. And we'll see where it is in the cycle for this particular month. So stars, that's those constellations and all the deep space items that we look at. Every day the stars rise, they're at their highest, and they set 4 minutes earlier. Now that doesn't sound like a whole lot, and you might not notice a 4-minute difference, but over 15 days, 15 times 4 is 60, and that's a whole hour. So it rises an hour earlier and set an hour later, and in a whole month, which is 30 days, let's call it, it's 2 hours, and that's a big difference. So something that might have been still an hour like it's still up in the sky an hour after darkness, may already have set for an hour when it becomes dark. So you lose things, but you gain things in the morning sky that come up earlier and earlier, so they're higher in the sky. So stars, for instance, stars that set an hour after darkness at the start of the month will set an hour before darkness at the end of the month, i.e. they will be gone from view, everything being equal. But in the fall, and this is why I'm kind of doing this, is not everything is equal. So the days are also getting shorter. So yeah, the stars are setting 4 minutes earlier, but nightfall is coming a little bit earlier, and it's about a minute to a minute and a half kind of on average on each side. So darkness is coming minute or a minute and a half earlier in the evening, and it's coming and it's ending a minute or a minute and a half later in the morning. So what this means is that our summer stars, they're still going away. They're going to go away, but they're not going away as quickly as you'd expect. So this is a good time to kind of catch Sagittarius because it's lingering a little bit. You can go out a little bit earlier night after night, and you can kind of catch it before it's completely out of view. So I'm going to just show you what happens in Stellarium, and I'll also show you kind of what is... Now there's a few little technical things with Stellarium. That's pretty good. So right now, what I have it set at, so this is today, I believe, October the 10th, and I've set it for 8:30, which is a good time. I mean, basically it's dark by 8:30, and certainly because night is coming earlier, it will be equally dark all the way through the month. So I'm going to just run time forward a little bit. You can see how the stars are changing a little bit, but look at that over there. So even though Sagittarius is kind of hanging in there, we've got the moon coming through. Now that isn't, it looks like a full moon. We'd have to zoom in to see it. It's basically a crescent moon. Oh. Sorry, was it not doing what I said it was doing? It looked perfectly good on the screen. I'm okay. All right, so suddenly the moon shows up, and this is by the 14th. So I'm going to just back out. So here's today. And you got Saturn sitting there. Let me just move this out of the way. And you can see the teapot of Sagittarius there. You can see the summer Milky Way. It's still up there. You can go out there this evening and catch it for a little bit, because you won't see it for quite a few months afterwards. But what happens is the moon is basically starting to come up. And the moon is going to stomp all over our viewing right through the middle of this period, zipping past Mars, and it just keeps, it's still in the sky. If I move over here, it's in the sky all the way through. Now we're on the 29th, so we're actually approaching Halloween. It's disappeared, but it's disappeared at 8 p.m., but it's still comes up at 9 p.m., so you're kind of stuck with the moon. But I'm going to try to deal with that. This makes this period actually a little bit challenging. So I'm going to... Okay. It's working. So avoiding the moon. How can you avoid the moon in this period? For the next few days, you can easily observe after the moon is set, because the moon sets pretty early. For instance, it sets at about 10:30 on Sunday night, October the 14th. But it just keeps setting an hour later, roughly, every night. So it's going to get harder and harder unless you really want to stay up late or get up really early, have a nap beforehand. By the 21st of this month, moon set is at 4:09 a.m., which means it's basically up all night. And you will have to wait until the 29th, which is almost the end of this period. We're getting close to Halloween, to get a bit of observing before moonrise. And even then, the moon comes up in kind of a, I guess it'd be waning gibbous phase at 10:25 p.m. So you've got a couple of hours, and at 10:25, the moon is up, and that's it. So the other thing that we have in this time period, and this kind of surprised me because I thought it was in January, we have the latest sunrises and the latest end of astronomical twilight or beginning of astronomical twilight because basically daylight savings time has been extended so long. So as soon as we go on to standard time, this is no longer the case. This is only because we have daylight savings time that runs pretty late. So on Saturday, November the 3rd, which is the last day before we switch to daylight savings time, astronomical twilight begins at 6:18. So at 6 o'clock, 6 a.m. on that morning, it is still perfectly dark, and it's perfectly dark for another 18 minutes. And the sun will only rise at 7:55 a.m. And I think the latest sunrise kind of early in January is 7:52 maybe. So this is actually the latest sunrise that you're going to get, but then after that you get to sleep in. But during that time you could say, fine, we're going to get up early, but the moon is in its last quarter phase, so it's sitting in the morning sky. So I figured that if only the moon was a half cycle off it, we were about, third quarter right now, we could observe Sagittarius in the evening and have a nice look at all those summer constellations that are going away. And then, well, we get new moon, we get to view whatever we want. And then towards the end of the month, we'll have the moon in the evening, but we can get up early in the morning and see a moonless sky with the winter stars. But it just doesn't work out this year. So just to recap the moon dates, the new moon was basically 2 days ago. First quarter is October the 16th. Full moon, which is called the Hunter's Moon and various other moons in different cultures' mythology, is October 24th. Third quarter is October 31st. And new moon is on November the 7th, which is just past this sky this month. So next month is pretty much the same deal. It starts with the new moon, and immediately you've got to work around the moon. Well, what about the planets? If the moon's around, the planets are still visible or can be viewed. Well, Venus is too close to the sun, so it's spent a long time in the evening and it's basically gone. It'll reappear in the morning. Jupiter, it's still above the horizon as it gets dark, but it's not very high above the horizon, so it's not really a great observing target. I'm sure there'll be lots of distortion. You can take a look at it first thing in observing, but it's not going to be ideal. Saturn is also well to the west, and it's also kind of approaching its end in the evening twilight, but it's still fairly high up, and it's going to be a good observing target right through the end of this month. So for the whole period, Saturn's okay, but you have to get it right after dark when it's the highest up, because it'll just keep getting lower and lower and set fairly early. So M&M. Mars continues to dominate the southern sky. There's no question. You go out there. I've had people at work say, what's that bright thing I saw in the south? Because I have this reputation as an astrologer or something. It's getting fainter, but there's... Yeah, we've had this discussion too. It's getting fainter, but there's nothing that competes with it in the sky. It really stands out. Personally, like I've looked at it with my telescope, I've looked at it with the CAO's larger telescope, and it's okay. I find the most striking thing is just seeing that red orb or orange orb just sitting low in the sky, and it just goes low right across the sky. And I can understand why the Greeks and the Romans thought it was the god of war, and it looks ominous to me, but also very impressive. So even if you just have a chance to pop out for 5 minutes, even from the city, you can see Mars. Mercury, my favorite, okay. So Mars is really impressive. Mercury this time is not very impressive. And it starts an apparition, which is an appearance in the evening sky, but it's not a very good one. In fact, it's a tough one, which I will demonstrate. So there's a few little... Oh, hit it again. There are a few technical tricks here in switching back and forth, but I really like to do the live Stellarium. It's like live television. It's great. So what I'm going to do is I'm going to tell it to go find Mercury. Oops. I typed it right. That would work better. Well, that's not too promising. What time exactly? It's 9:30. So the other thing I have to do, and you'll see the reason why, is I have to go in here, and this lovely this lovely landscape that we have by default, I have to change it to ocean. So that's also not good news, because the trees aren't really very high. So you can see right now there's the sun and Mercury's kind of hanging out there. That's not so good. I'm going to make it maybe 1830. And it's there, but you can't see it. Basically, what I look for when I go through and say how visible is Mercury or anything, I look at the size of the dot, because Stellarium actually adjusts the size of that dot for you depending on how bright the object is and also how much atmosphere it goes through, so it will show you the extinction as well. So basically, if you see a nice fat dot, it means, yeah, probably are going to see it, and if it shows a small dot, it's going to be harder to see, and if it shows no dot, well, yeah, that's not too good. So I'm going to just step time forward. Actually, I'm going to step it up a little bit too. I noticed that we're in towards the end of the month. Well, it has to be the end of the month. So this is the 23rd, as you can see here, of October. It's sitting below Jupiter. Now, can we make it visible as a dot? You can see how Jupiter suddenly pops out. And that is Stellarium saying now it's probably going to be visible as the sun fades. So it's actually quite... Mercury doesn't, so let's go forward a day. You can see Mercury's got a little bit of a dot there now. It passes, but that's easier to read. It's half a degree above the horizon, which is not very helpful. And if we run time back, well, maybe you'll be able to see it on the 27th, right below Jupiter. If you can see Jupiter, at least that's a good guide point. But I like it a little bit more like this, where it's on the same level as Jupiter, because we can run the time backwards a little bit, and it's a little bit higher in the sky, and so is the dot, but it's tough. This is going to be a tough apparition. I'm going to try. Will I succeed? That's a good question. As you can see, it kind of just zips along the horizon rather than climbing higher in the sky, and then it just goes away. Well, that's the way it goes. So difficult.
Have a good southern sky that you can...
I've got an easy one for mornings. It's easy. I've got a great sky, but in evenings, no, I don't. And I've actually had people accuse me of doing questionable things with binoculars when I've been trying. So it wasn't that funny at the time, actually. But his use of the terminology that he was accusing me of was a little bit off too. Okay, so U and N, United Nations. Well, it's Neptune and Uranus or Uranus. Neptune is well placed. It's close to opposition, but honestly, it doesn't make any difference with these distant planets. They're about the same distance all the time. Our little puny orbit hardly affects our view of them. And Uranus rises before midnight, and Neptune is up a fair amount in the southeast once it gets dark. They aren't a great view in themselves, in my opinion, and I've seen Neptune in our big scope in the CAO, and it's kind of like... So true story, we didn't have quite the auto go-to set up quite calibrated properly, so we said, go to Neptune, and it wasn't quite in the field of view. We're bumping around the telescope and going, is that Neptune? Is that Neptune? And this is with a large telescope and a good eyepiece at high magnification. So it's not that interesting to look at itself, but I find looking for the moons, and I've done that at the CAO a couple of times, is really interesting because they've got moons that are like almost at the edge of visibility. So it's a real challenge, and Stellarium, again, my favorite program, helps you, and I'm going to just show you. The other thing I have to say is you can see them with binoculars, and in fact, the other night, these are cheap binoculars. These are the Canadian Tire $50 special whatever binoculars, so nothing fancy, and I saw both Uranus and Neptune in those last night, just by going through the Stellarium, and I'm going to show you how that works, because this is one of those interesting tips I hope that people will find useful. So I'm going to switch to Stellarium, press the magic button, sufficient times to make it work. Okay, we don't want Mercury anymore. Okay, so I'm going to just put it to I'm going to put it to yesterday because that's when I viewed it, and I'll show you how I viewed it and what will happen over time. So that was yesterday, and obviously I viewed it at, let's say, about 9:30. That sounds pretty good. So Mars, is, like I say, is still dominating in the sky. Where is Neptune? Neptune is somewhere. There it is. So, like, how do I do this in binoculars? And I thought binoculars was a lot easier than telescope. Here's how it worked. So I was just looking out, and these three little stars there, like I noticed them in the sky, and what that's interesting is that part of Aquarius, which it is, and I thought, and then it showed this Neptune there, and I thought, well, if I can see those stars, can I use them to kind of guide me over to Neptune? And in fact, that's the case. So if we go up, you see these, like that's the water jar, these three stars. One thing I'll say about Stellarium is they compress the star brightness. Like stars vary in brightness incredibly. Asterius is like 10,000 times brighter than the dimmest star this program shows. They can't make the dots that big, so everything's a little bit compressed. So I will assure you that this in a reasonably dark sky definitely stands out. And, sorry, the little squiggle stands out. Sorry, this little squiggle, I'm getting a little lost. So what I said was, okay, from that little squiggle, if I go up and across, and from there I kind of go down, there's a bright star here, and Neptune is basically in between. So sure enough, I basically just set my binoculars there, went across there, and what you can see here is there's this nice little box pattern, and that is perfectly obvious in binoculars. So the other interesting thing is Neptune, and you can see the magnitude. So we have to look up here because it's really hard to read down there. Whoops, didn't mean to do that. Magnitude 7.83. This is a 6 magnitude star, 6 something, 7.45, so that Neptune's still dimmer than that, but that's about the same brightness as Neptune. I looked at it and said, yep, that it is. The interesting thing, the first interesting thing is that if we center on it, if then we do the same thing over a few days, you can see how it moves, so that pattern will keep changing. But you should still be able to pick it up in binoculars, especially if you found it once. Practice makes perfect, works great. And this took me like 10 minutes to do, because once I realized that I had some guideposts to it, I think with a telescope it's actually harder unless your go-to is working really well, because you have to star hop and your field of view is small. With the binoculars, it's a big field of view. So I'm going to zoom out, and I'm going to go over to, sorry, I'm going to turn on the constellation patterns and names just a little bit, because I had to use, oh, we really zoomed in there. So for Uranus, I actually used these three stars in Aries. They're pretty distinctive too. They make a little bow or arc. And these aren't very bright stars, but I could still kind of say, okay, go to the arc and go close to this star, but just a little bit off to the left. And in this case, Uranus is actually part of a little pattern. Sorry, it doesn't look the same way that okay. Let's center on it. So there, I saw this little angle, and then the straight line, and again, I could match the magnitudes. I'm not going to do it for this one, but say, yeah, that for sure is Uranus. And there it is. And again, if you can go back over time. Hello, please center. Again, you'd be able to go back and watch it, like with just binoculars, you can see the motion. You don't need anything really fancy. You don't need to do astroimaging. The other thing, though, if you do have a big telescope, and it doesn't have to be the CAO, but the CAO is a great place for this, is if we zoom in, Uranus has got this menagerie of moons, and they're all very faint. So they are at the limits, in my opinion, at the limits of visibility. It depends on the night. It depends on how high it up. Like the planet itself is not very interesting, but trying to pick off those moons is quite nifty. And I think I've seen, Miranda, and then we have a discussion, is that Ariel or is that some other moon? And Stellarium does give you a live view of what the moon layout is. And that's a lot of fun too. Like, I find it a very interesting challenge. With Neptune, it's not so good because Triton is the only moon you can see, and all the rest of the moons are really, really faint. But you can see Triton. Uranus is a little bit more interesting for its moons, in my opinion. So, I need to remember all these steps. Okay, so that is it. Meteor showers, well, gee, never say never, I guess, is the lesson I learned. There are the Orionids, which are from October, on the night of October 21st, 22nd, but the moon is pretty much in the way. And the Taurids are November the 5th, and both are not really supposed to be really exciting, and meteor showers, and I haven't read any speculation that there could be an outburst. To be honest, a few places, like in the last week, said, there could be an outburst of the Draconids, people should watch out for it, but probably not. I haven't seen any indication of this, but like I say, you never know, and you could be treated to a meteor shower, and that's always a nice thing. Okay, so there's some dim stars to the south, and I just want to kind of cover some constellations. I've got a bit of time, right? Excellent. Okay. So I'm going to flip over. Okay, good. So we zoom way back out. We don't really want this anymore. So these are the southern constellations, and there's the only patterns that I can really recognize in Aquarius and Pisces. In Aquarius, I can recognize this water jug, which is not laid out like that at all in this line art, which is pretty default. But this is really distinctive. It does stand out. And for Pisces, there's a circlet here. And again, that does reasonably stand out. And there's one bright star in the southern sky, which is Fomalhaut, and the rest of the constellation you probably won't see. It actually looks not too bad in the southern sky, which I've had the opportunity to see. But compared to Mars, it's not that bright, but it's still the only bright star down there. And the constellation that I kind of learned, and this was actually back in September when I was up at the CAO and I got up like at 3 o'clock in the morning, is Cetus, which is probably not a very useful constellation. It has two stars that are decently bright. That star is the second magnitude, so you probably can see it if you're someplace dark but not really dark. It has another bright star here. And that one is those are probably the only two stars that are visible from anywhere close to Toronto, but if you get out, you can see this pattern, and you can see the head, which kind of resembles the circlet of Pisces, but it's further down. But just looking at that shape, that doesn't look like a sea, like a whale to me. It looks like a rubber ducky, so I'm calling it the rubber ducky constellation. And you probably, if you go out there and you learn it, you will not forget it, because it kind of floats across the sky. I guess, yeah, it kind of floats backwards across the sky during the fall skies. The head is that way, that's right. So it's going something backwards. Yes?
So city office work, union sings.
Okay, so we have that. Let's see how. So the M30s, and the last thing, hopefully I have time for this, is to do the M30s, which is M31, M32, and M33. And this is kind of interesting. Most people, so I'm going to pop over to Stellarium, because I think it's hard to time these presentations, by the way, because the real-time stuff takes a bit in the switching. So the way I think lots of people know how to find Andromeda, you find the great square of Pegasus, which is actually a great rectangle of Pegasus, but no one wants to call it that. But from where we are, always in the left side when you're looking at it, and the upper left corner, there's Andromeda. In fact, this star is shared between Andromeda and Pegasus, and there are these quite bright stars going out that way. And you go up from the second one, you go up 3 short steps, and you can already see the fuzz there. There's M31. Excellent. Most people know how to find it. M32, like how many people go out and view M32? Yay, guy. And M32 is somewhere underneath. I guess that's M32. Yep. Honestly, when I look at it with a telescope that may be the size of Messier used, I go, it just looks like a fuzzy star to me. So he must have been using a lot of magnification and looking very carefully to say, that is a fuzzy, and I'm going to put it in my catalog. Compared to M31, it's like a huge difference, and it's quite amusing. Now, M33, which is the galaxy in Triangulum, I have heard is the most distant object you may be able to see with your unaided eyes. But how do you find Triangulum, and how do you find the galaxy? And I realized I actually didn't know, like, Triangulum, who cares about that? It's like 3 dim stars, and they said, well, yeah, it can be a triangle. The way I think about it, though, and the way it works for me is, remember I did this business with these 3 stars, and then there's Andromeda kind of up. M33 in Triangulum is kind of the opposite of M31. So it's kind of up there. If you go down there, and you go in about here somewhere around here. Oops, did I miss it? Up, up, up. There we go. So I'm going to tag it. Oops, type star. Sometimes Stellarium has problems picking stuff out. It's over there. Yeah, it's not doing the name for me. If I turn on deep sky objects, there's a million of them. So it's basically from this middle star from which you go up to see the Andromeda galaxy, you go down to see M33. I'm not sure that I've seen it in dark skies. You need really dark, really clear skies, and it has to be high up. I used those binoculars, and I'm going, is that it? Is that it? It is actually very big, but it's also very diffuse and faint. So eventually I'm going, yeah, there's a big, really faint patch, and that is M33. So if I can barely see it in binoculars, I'm not going to see it with the eyes, and it was kind of humid. But it's another one that is worth trying if you're ever out and it's a cold, clear, crisp night. And later in the year, it's even better because it's higher in the sky. So that's one that I recommend that you try to look for. In a telescope, I don't know, in a small telescope, it's probably just a large, very faint fuzz. But astroimagers should have lots of fun with it. So, just about done here. So, the other thing you can do is you can get up early. Like I say, the latest sunrises are coming up at the end of this month. I got up at the CAO at 5:30 this morning. I just kind of woke up. Didn't make a late night of it because the clouds were coming in and the lightning was flashing. I went outside and there was Orion right up front and Lepus the rabbit, I guess, beneath it. And I could saw the path of stars of Eridanus there. It was a very impressive view just from the balcony. I didn't really want to set up because it was 5:30 and it was going to be getting light. But you can get a great preview of the winter stars and even some of the spring constellations. Leo, which is a spring constellation, is already on its way up as it starts to get light. I'm going to skip the Stellarium, but like I say, if you go out there at 5:30 in the morning, it'll be dark. Towards, like for the last half of this month, it is still astronomically dark at 6 a.m. Astronomical twilight only begins about 6:02, and then it creeps to 6:04 and 6:05 and 6:06. It will be dark at 6 a.m., and 6 a.m. is not outrageously early. I'm at my desk at the city at 6:30, so that's my take on that. Finest deep sky objects. I have this old booklet that was published, and I'm missing the cover. I've had this for ages, and I think they have 50 in them. They have 105. Wow. So I actually used it for the first time seriously last night. And 19 Piscium has a very red color, it says, and I kind of looked and said, yeah, it's a red star. Eta Cassiopeia is a nice double star, but it took higher power to actually resolve. Gamma Andromeda, it's like another Albireo. I had this discussion with Blake. Usually when there's a contrasting color and one star is brighter than other, the brighter star is the redder one and the fainter star is the bluer one. I think that is because evolution, stellar evolution, means if you need a really bright star, it will have moved to the supergiant phase, and the blue star is still pretty bright. So it's an interesting thing to think about. I don't know that anyone surveyed it and done this survey saying, well, you know, all the colorful doubles, the brighter one is almost always the yellower or redder. But it is like Albireo on both of those. The bright star is kind of yellowish, and the dimmer star is greenish or bluish, depending on your impression. Delta Cepheus is a very easy wide double, and it's a prototype Cepheid. Gamma Ariatis, I think I saw that, but the clouds were coming in, so I kind of gave up. But these are according to these people, some of the finest deep sky objects, and I'm going, well, that's interesting. How much time do we have, or we don't? We don't. Okay. So, I mean, this stuff will go up somewhere, I'm sure, and it's live broadcast, so you can take a look at it. Actually, because I have just 1 second here, I will show you this very red star because it's easy to find. Oops, we'll zoom out. Remember that circlet in Pisces that I said is pretty obvious? 19 Piscium, I think you can already see it. According to Stellarium, it's quite red. It's got a blue minus B. It's got a color index of 2.52, which is quite red. So even in binoculars, I point them up there, and yeah, I can see it's a red star. Whether it's the finest object of its kind in the sky, I don't know, but actually I'll finish the presentation on that note. So that's it. Does anyone have any questions? Hopefully I can answer them.
I don't know if you or thank you. I don't know if you or anybody else knows. Are the dust storms in Mars over, or is it still hard to see anything? I haven't looked at Mars recently, but I think it's still closer than some of the oppositions that come in 4 or 5 years. It's
still pretty close, and as far as I can tell, and I have seen details on Mars. So yeah, I think it's fading out. Whether it's completely faded out, I'm not sure. To be honest, I found looking at it with a telescope, even from the CAO, a little bit disappointing. It could have been because of the dust storms, though. Yeah. Okay. Thank you very much.
Okay. Thanks everybody. I've got some notes that I'm going to have to look at from time to time, but some of it I don't need to look at the notes for. So I feel kind of privileged that, pardon me, over the years I've gotten to sort of check out places associated with some of the great famous dead astronomers and thinkers from history of physics and astronomy in particular. So in the past, that would include people like Newton and Galileo. Haven't gotten around to doing Kepler yet. I have done Tycho Brahe. Anyway, towards the end of the summer, finally, I got around to doing Copernicus, who was on my hit list for quite some time, as you can imagine. So my talk, which, by the way, I didn't time out, so we'll just hope that the length is okay, and if I start to go on for too long, just come and stop me. But it's sort of mostly travelogue. There's not too much science in it, but I will say a few things about sort of heliocentrism and stuff like that. I guess the first thing to say, except for Poland, the main place where Copernicus hung out was his brief period as a student in Bologna, Italy. So I don't have any pictures of Bologna, although I was there a long time ago, but none of those pictures are included in this talk. So we're going to just talk about the Poland situation. Let's see if this works. Yeah, okay. So just from Google Maps, these are the 4 key locations that are going to come up. Warsaw and Krakow are big enough that Google already sort of acknowledges their existence. Turin, and I apologize for any pronunciations that I'm not getting exactly right. The key thing with Turin is not to pronounce it exactly the same as you would pronounce the Italian city Turin, like the Shroud of Turin. They should be different, but I have not mastered these subtleties of pronunciation. And Frombork, which is a very important city, it's where Copernicus lived for the final decades of his life, and in fact where he's buried, so that's going to be significant. So that's good, not too much geography to keep track of. This is Warsaw, and near the geographical center of the city, and of course what you're seeing there is a very grand, larger than life-size monument of Copernicus. Of course, he's holding a little model of the solar system, so you know it's him. And one thing that strikes you, well, just get a closer view here for a second, is that wherever you go, you see something like this. Well, this being Warsaw, it sort of has maybe the grandest one, but I kept running into, full-size monuments, sculptures, busts, portraits, or just his name, sort of everywhere. I mean, he's just sort of, him and Chopin, the pianist, are sort of the biggest national heroes in Poland. So you just sort of run into him everywhere. Who's the equivalent for Canada? I don't know, is it like Wayne Gretzky or something? Or who? I can't think of a single individual where like everywhere you go, or Drake, yeah, or Tim Horton or something, right? Yeah. So, but he really is everywhere. Just very briefly about his nationality. So, of course, today Poland is Poland, but politically, what we think of as Poland didn't exist in, well, that's not quite true. It did, but the boundaries kept changing and things were quite different. So, in fact, the language that he spoke at home was German. The city that I mentioned a moment ago, Fromberg, was called Frauenburg in his time, the German name. Actually, each of those cities has a German name. Because, like I say, boundaries have shifted and things have gone back and forth. So, although he spoke, he spoke presumably to his parents in German, but later, when he became a scholar, he started writing in Latin. So he used what we have here as we remember him as Nicolaus Copernicus. This is the Latinized version of his name. The Polish version is a bit different. It has more consonants and is a little harder to pronounce. But he was a subject of the King of Poland. So, I mean, there's a pretty good argument to just call him Polish. At any rate, I don't have a dog in that fight. And again, the battle has sort of like been won, but he sort of is Polish for all practical purposes. Let's see. So let's talk about the city of Turin. Now, this is a pretty significant stop. Actually, it's a lovely town that's sort of reasonably popular with tourists, although it's certainly not in the top tier because more people go to Krakow and Warsaw and Gdansk than they do to Turin. But it is quite lovely, sort of many elements that are still around from the medieval and early Renaissance period. Now, it's a little hard to tell because this is the wide view, but that, sure enough, that is Copernicus, this time in bronze, I guess, on a big pedestal or plinth right in front of the old town hall. Now, his birthplace is just down the street from there on Copernicus Street. And as you might expect, it's sort of, a museum, and I'm not going to go into sort of the things you see inside it are just sort of the things you would expect to find, a lot of period furniture and just a few scientific instruments and things sort of dating from that period. And probably the only catch is that we do not know for sure that he was born there, and the reason is that his family owned more than one home. But we do know that this house, which still, survives and is in pretty good condition, and some elements of it, date back to the 15th century. The family, it belonged to Copernicus's family beginning in 1463. So it is a Copernican home, but whether it's the Copernicus house, whether it's the actual house where he was born, we do not know for certain. He was born a decade after that time that I mentioned. So he was born in 1473. Just a couple of biographical details here. The son of a wealthy merchant. He studied first at the University of Krakow, so I'll say a little bit more about Krakow shortly. Later at Bologna, where he focused on canon law. These are the sort of the church laws, the laws that govern the rights and responsibilities of church leaders. Although he never took full holy order, so he never became a priest, but he was a cleric, pretty high up, just not a priest. Eventually, later in life, and he did also. Oh yeah, I mentioned Bologna, but there was also Padua. So he did study medicine at Padua, the other Italian city where he spent a little bit of time. Now, his uncle. Let's see what's next here. Oh, okay, just back outside. Yeah, so this is the old town hall. There's some exhibits in there. The statue, once again, that we already saw. Actually, I will just say that, so aside from seeing the birthplace or the house associated with Copernicus's birth, there was something else I wanted to see, and I knew I would find it in the town hall, and that's this very famous portrait. And you already saw it at the beginning. So slide number 1 was just a little, the title slide, but I had the Wikipedia. If you type Copernicus into Wikipedia, the first thing you see is that very famous portrait that you've all seen 1,000 times. He's wearing sort of a red coat. And I know it's on display here, so I thought, all right, that's fine, I'll go and I'll check it out. And I thought, well, surely it will be, like in its own room with maybe like a spotlight pointed at it, or maybe not, because you don't want to fade the painting, but like maybe a big arrow pointing to it or something. So it was actually just the opposite. I went there and there's like a row of like a bazillion portraits of famous people. And you just have to know. Now, I don't have the laser pointer, but you can see it. There he is. It's third from that. Yeah, third from the right is Copernicus, and there are different copies of it in other museums and different places. You actually will say, "Oh, that's great." Yeah, exactly. So that's just kind of funny, and also there was nobody there. I mean, there were some, there were other tourists, but I sort of had the room to myself for a couple of minutes. So I just thought, it was a little bit of irony because. I thought, oh, it's going to be this big thing. It's actually, you can see the scale, right? It's actually not that big. Yeah, there it is. Just like I say, if you go to Wikipedia, it's the first image that you see. It's been reproduced everywhere. Okay, so let me just I'll just rest it on. That's the same sculpture we saw before. This is the monument just outside of Town Hall in Turin, and just a few more biographical things. So Copernicus's uncle was a powerful bishop, and after his father died, it was sort of the uncle who looked after him, and later the vice versa too. Copernicus had his medical training and would sort of look after his uncle's health needs later in life. So the uncle supported Copernicus's education and his travels, and in 1497 he settled in Frombork, which, as I say, was known as Frauenburg in Copernicus's time, in the province of Varmia on the Baltic Sea. And it's quite small, and to this day it's just not a very big place, but which is fine. It makes it easier to see all the tourist things on foot. So he was appointed as a canon. So again, this is a position just a little bit below that of priest. And after returning from Italy with his medical degree in 1510, he remained in Poland for the rest of his life. As far as we know, he lived pretty comfortably. Well, let's see. Let's get some. See if I can get us to Frombork. Oh, okay, I'm getting a little ahead of myself because I have a couple of things to say about Krakow, so let's take care of that. So in Krakow, where, as I say, he did some of his early studies. Now, Krakow is this hugely popular tourist destination, so there's like a whole bunch of things you can do in Krakow, and you'll have a terrific time. But I'm just going to focus in on the one site that's sort of associated with Copernicus, which is the Collegium Maius, the oldest of the college buildings. This is, sort of the arch, the courtyard with the arches. This is inside the assembly hall with just, painting after painting of important people from long ago. Now, so you turn the corner from here, you go into something called the Copernicus Room, and you have all these exhibits sort of associated with Copernicus himself and with the history of astronomy in general. If you spend enough time doing this, I mean, eventually the exhibits sort of blur into each other, because I saw something similar in Frombork and something a little bit similar in Turin. But this one really is, it's first rate. It really is a great place to spend a couple of hours. And the only one of these that I'm going to just zoom in on for a second, you can see it in the top left there. You're thinking, all right, well, that's probably not a photograph that Copernicus took, but it's a photograph of the Earth, and maybe you can guess who it's from. There's a movie coming out soon, isn't there? So this is actually from Neil Armstrong. That's right. It's signed by Neil Armstrong. It says, "To the Copernicus Museum, Krakow, on the 500th birthday of a giant." So that's kind of neat. Yeah, I didn't know it was there. I wasn't really expecting it. But that's kind of cool. In just a few weeks and a little bit, we're coming up on the 50th anniversary of Apollo 8. Well, you know that because it was the cover story on Sky News, but I just thought I would mention it anyway. It's kind of cool. Okay, let's get us to Frombork. Frombork is quite small. I think I probably already said that, but I'll say it again. It's kind of a small place. That's the bus stop. I guess that's the southbound bus stop, and somewhere on the other side of the street is the northbound bus stop. But you get off the bus, and up behind you there, I mean, that is the cathedral, which is sort of where you're trying to get to. So and as you'll see in a moment, it's not just a cathedral. There's a whole fortified sort of complex with the cathedral sort of inside at its center. Oh, and at the name of the bus stop is Frombork, underneath it, Copernica, right? Just to make doubly sure that you're getting off the bus at the right spot, and you're not at some other Frombork. You're at the Frombork associated with Copernicus. So they don't want anyone getting mixed up over that. Okay, here are as I say, it's kind of like a castle/cathedral. So the cathedral is the dominant architectural thing inside it, but the whole thing is sort of a fortified complex dating from the Middle Ages. Now, with that up there, let me just say a few things about Copernicus's life in Frombork. He lived comfortably. He had an income from the region's tenant farmers, but he had a second income from the cathedral, so that's a good deal if you can get it. So the whole two-income thing. And he was pretty busy because he was now trained as a medical doctor, right? But he also had his administrative duties within the church. So he had a lot of things going on. And every time his uncle needed him for something, he had to go. So, and the uncle had sort of, medical problems of different kinds, and Copernicus had to always be on hand to attend to him. But he did also study economics, cartography. He looked at the problem of counterfeiting and how to deal with it. But while all this was going on, he was definitely interested in celestial matters, and this, I think, even from an early age, this was the case. He took great interest in an occultation of the star Aldebaran by the moon in 1497 and a lunar eclipse in 1500. So he was still quite young at that time, and he was hooked. Okay, so. What do we find at Frombork? Well, this is as I say, the sort of cathedral complex here is the main entrance, the gateway, and you're going over the moat. I'm not sure if the moat had water in it at some point. It seems like a good bet that it probably did. It's dry now, but it's pretty cool. The whole thing has a sort of a Monty Python-esque quality to it in terms of its. All right. More exhibits, of course. There's as much history of astronomy as you could possibly want. I really like what they did with the ceiling, with the sort of the artistic rendering of the constellations and illuminated at that. Let's see. And more, I'd have to go online I didn't memorize the details of that upper left painting, but it's reproduced a lot. So you have seen that image before. It's a much later, it's a 19th century, impression of, I think the title is something like Copernicus and God, or Copernicus Speaks to God, or something like that. But I only know what I read online. And of course, all kinds of medallions and things celebrating our friend Nicky. I'm trying to figure out the best nickname, whether it's Nicky or Copy, and I don't have a favorite between those two. But I guess it's not that many syllables to call him Copernicus. Okay, his book, De Revolutionibus Orbium Coelestium. I don't know very much Latin. I just know that. But in English, it's On the Revolutions of the Heavenly Spheres. The story of how it got published is pretty interesting, but I probably don't have time to get into it in too much detail. But I will just say a few things about, why Copernicus is famous in the first place. So this is the book. It was published in the same year that he died, 1543. There's sort of a legend that it was he was finally handed a published copy as he lay on his deathbed, and then I don't know, did he drop dead right away when he saw it, or did a couple of days go by? I'm not sure. Plus, there's probably a bit of urban myth behind that. Okay, so why did he come up with this? So the diagram is exactly what you expect, right? It's in Latin, of course, so the sun is Sol, S-O-L in the middle. The planets are orbiting around. The third rock from the sun, so to speak, is us, and we have our own little moon going around us, as you can see. So this is the modern, if you're like me, when you were 9 or 10 or 11 years old and you didn't know what to do, you started sort of drawing diagrams like this. In my case, it was either, a brontosaurus or this, right? Those are the two things that I sort of like to draw for fun. And never to scale, because nobody has that much paper. So you sort of compress everything in the same way that Copernicus did. So the ancient Greeks had a pretty good understanding of where things would appear in the sky. They didn't, as we would now say, they didn't have the physics right, but they could predict what was going to happen where. In fact, even the Babylonians could thousands of years earlier. So do we need a new way of representing the universe? That's a good question, right? So apparently, this ancient Greek astronomer Ptolemy sort of set up a detailed mathematical account of how things worked in the heavens, and it was pretty good. It was reasonably good for predicting the positions of the planets. So why change it? Well, ultimately, it may have come down to sort of a question of aesthetics. I think Copernicus. Well, the details are a bit involved, but I think he liked the idea that once you put the sun, it's basically a question of swapping the position of the Earth and the sun. So you put the sun in the middle, have everything go around it, and then suddenly some things just become a lot simpler. His system still used epicycles. The ancient Greeks had epicycles to sort of make everything work out in fine detail. We didn't manage to get rid of those until Kepler came along just a little bit later and said, well, you've got the shape of the orbits wrong. They're not circles, they're actually ellipses. So Copernicus was a bit old-fashioned in that sense. He didn't know they were ellipses. He stuck with the idea of circles, which were thought to be sort of a perfection, the ideal geometric shape. Well, imagining it to be, imagining that they had to be a certain way because that's how God would have wanted it, that only gets you so far. You do sometimes run the risk that the real universe we live in isn't quite like that. By the way, a really good book that came out earlier this year that talks about that in the context of string theory and the multiverse is called Lost in Math by Sabine Hossenfelder, so you can check that out at some point. So at any rate, it may have been aesthetic considerations that eventually sort of got him to try this, and then he hesitated to publish for quite a long time, and it wasn't until a German mathematician named Rheticus came to visit him and said, hey, what's this I hear? You got this thing? And Copernicus said, yeah, but it's on a shelf here. Nobody wants to read it. Oh yeah, everybody wants to read it. You've got to publish, and sort of dragged it out of him. And then eventually it was published in Germany. So it's interesting, here we have a Catholic cleric agreeing to have his book published in a Protestant city some hundreds of kilometers away, and he dedicates the book to the Pope, so it's a complex set of affairs. I'm not going to go into that in too much detail. let me just see here. Yeah, so Copernicus later writes of the, quote, marvelous symmetry of the universe, close quote, afforded by this system. So there was something that he saw a kind of beauty in it. He writes in De Revolutionibus, truly indeed does the sun, as if seated upon a royal throne, govern his family of planets as they circle about him. And he did have a sense that there was a bit of controversy, or that people would find it a little bit shocking. I should say, you know, those who would bother to read it. It's a highly mathematical work, and it's written in Latin, so it's aimed at a certain audience. The best book about who read it and what they thought of it is called The Book Nobody Read by Owen Gingerich. And of course, the title is ironic. It's a quote from Arthur Koestler, who said that nobody read it, but in fact, quite a few people did read the book. Let me see. Oh yeah, so in the very beginning of the book, in the dedication to Pope Paul III, Copernicus writes that some people, as soon as they find out about this book I have written on the revolutions of the universal spheres, in which I ascribe a kind of motion to the earthly globe, will clamor to have me and my opinions shouted down. So he did sense that there was going to be some controversy. But as I say, then he died, so he escaped all of that. Galileo, who lived just a little bit later, would get into, you know, a bit of a thorny situation in that regard. Topic for another day. But yeah, he clearly said, so why, I know I don't have too much time to go into this in detail, but why is it a shocking idea? I think the number one reason why it's a bit shocking is it means that the Earth must be hurtling through space. Now, here we are sitting in an auditorium. Does it feel like we're hurtling through space? I mean, basically, no. Like, I know we're all a little bit too smart to be asked that question, because, well, I know moving at such kilometers. Yeah, but if you didn't know that, does it feel like we're hurtling through space? And it sort of doesn't. And then you have all the usual arguments. Well, how come the clouds don't blow off? You know, how come the birds don't blow? So we sort of, now we have pretty good answers to that thanks to Newtonian physics and ideas of inertia. But remember, none of that existed at this time. So it was kind of provocative. Okay, let's see. And I mentioned some of the hurdles in getting it published. When it was finally sent off to, I guess, Nuremberg for publication, a Protestant clergyman added a preface anonymously. We now know who did it, but a preface was added that Copernicus knew nothing about. The preface said, "Oh, here's a book containing a hypothesis. So treat it as that. Don't take it too seriously about, you know, what the universe is actually doing this or doing that. It's a hypothetical thing. So knock yourselves out with this hypothetical work." So I mean, the joke is that when Copernicus got the copy and saw the preface, that's what killed him, right? Because that's again a bit of urban myth. Okay, so just a few last things to get through. So this is the cathedral. And so this is where Copernicus worked, shall we say. I had elsewhere, I don't really have a good photo, but he had sort of his quarters in one of the towers, not the grand belfry tower, but the other tower. And this was his vocation. This is where he spent most of his time. Also, it's a great place to see an organ concert too. And this is the tomb. Now, you might ask yourself, why is the tomb so darn modern? So there is a bit of a reason for that. And the reason is that for a couple hundred years, nobody knew where Copernicus's remains were. I mean, they've sort of figured that he's got to be buried down there somewhere, but just nobody seemed to be very certain. So in 2005, archaeologists found what they believed to be his bones underneath the floor of the cathedral. And as you can imagine, it's sort of difficult to be sure that you're right about this kind of a thing. But they found the bones of someone who died, a man dying at age 70, so that is the right age. And the facial features sort of matched the known portraits of Copernicus. And the DNA from bones, again, I only know this because I sort of looked it up, but the DNA from the bones matched traces found on a book that he's known to have owned. So, I mean, I guess if you add that up, it's sort of reasonably compelling. So, in the spring of 2010, he was given a second funeral, and his remains were buried there in Frombork Cathedral. So they were found in the cathedral, examined, and put back in the cathedral, but this time they're marked. So now we know where they are. And you might be wondering, oh, okay, well, I'll zoom in for a second. I have something to say about the little window at the bottom, but first, just the inscription. There it is. It's so it's bilingual, but the two languages are Polish and Latin. The Latin one is at the bottom. So, I mean, I can't translate word for word, but basically it says, you know, astronomer invented the heliocentric theory and was a canon or a church official from the province of Varmia. Okay, and now I said I would say something about the window at the bottom. The window lets you see the coffin. So there he is. He's in at the 2010 burial includes that same painting that we've seen a bunch of times in miniature in a hexagonal frame on the coffin, and there's a little glass window so you can see the coffin. So that's cool. I don't know how many other dead people have gotten this exact treatment. Probably not very many, but I guess they're just afraid that the remains are going to disappear again, or they're going to lose track of them. So this way you can sort of see. If anybody moves the coffin, we'll know. I think that's basically it. Oh wait, I just have a couple more images. I mean, that's it for me saying things, but I have a couple of pretty pictures. So when you climb up the former Belfry Tower, you get this view, which is really wonderful. So, of course, you have to climb a bunch of stairs. I did a lot of stair climbing on that trip, just as well. I lost a little bit of weight on this trip, which is, for me, kind of an unusual thing. But there's the Baltic Sea in the background, all these fortifications. The main gate is on the lower right-hand side. You can see sort of how small the town is, right? I mean, there's this, and then there's like a few shops and homes, but really there's not much else. And oh yeah, and since our iPhones all have this panorama mode feature, there's the mandatory panorama, and really that is so behind, in the upper left, like that sort of is the town, and then you've got the ocean, and that's it. So there you go. So Frombork is a little bit off the main tourist track compared to those other places that I mentioned, but yeah, pretty much worth it. And I'm gonna stop there. Thanks very much. If anybody has any questions, I'm happy to, yeah.
Are those solar panels they're putting on that church?
I don't know. I guess they could be, right? Well, I don't know. I mean, there is, they did need to calculate the date of Easter. I mean, church people over the centuries did have a strong interest in where the sun was and its altitude and its azimuth and a bunch of things. But yeah, I don't know. But I guess if it looks like solar panels, then it probably is, right? Because it's a little bit hard to figure what else it would be. Yeah, I don't know. It's facing the right way, isn't it? Or, yeah, it's facing south. The Baltic Sea is in the north. Yeah, it's facing south. It's a good direction to have solar panels. Anything else? All right. Oh, wait. Yep.
He lived in a cathedral. Didn't you say his uncle was a bishop or something or other?
Yeah.
I'm curious to know, and you probably didn't get the answer to this, but did he talk to all these religious people about what he was working on, or did he just do it in private and not tell anybody?
Yeah, great question. So the question is, did he talk to people about what he was working on, or did he do it in private? And I think mostly in private, but not completely, because in I'd have to look it up, but I think 1515 or something like that, he published like a really short version of what would eventually be De Revolutionibus. So I think it's called the Commentary, or in Latin or whatever, Commentariolus or something like that. But it's like a short pamphlet type thing that kind of lays out the basic ideas, but it wasn't sort of published. It was just circulated to people, to interested parties, so educated people of Europe. So I don't know how many people that is, but probably not very many, like a dozen or something like that. So as often happens in academia back then, if you have an idea that you think, it's like beta testing, right, or whatever. You show it to some people who are going to give you some feedback, but you're not quite ready for prime time. So you show it to a few people, and like I say, it's not clear that he would have published at all if Rheticus hadn't visited him and encouraged him. And by the way, there is a stage play about that, about the meeting of Rheticus and Copernicus. It's by Davis Sobel, who of course wrote Galileo's Daughter and took part in a bunch of PBS documentaries. The book, she wrote a book called A More Perfect Heaven, but there's also a play, and a version of the play is embedded in the book, but then later was published on its own, and the version that was published on its own is better because she made some changes to it. So, you know, if you Google Davis Sobel play Copernicus, you can get the name for it, but it's kind of cool. It'd be nice if somebody staged it around here or something, because I'd love to see it. But
I was wondering what the main trigger was that led him to realize that the Earth is not the center of the universe, that the sun is. Was there a main trigger that...
Yeah, so, I mean, I guess the short answer is I don't know, right? So the question, you know, what triggered him to do this kind of switch? Because the diagram that you saw in De Revolutionibus isn't that different from the diagram that Ptolemy would have had in his book from, you know, 1,000 and something years earlier. So it's kind of a swap. It's a shift of perspective. It's putting, you know, kind of changing the relationship of the Earth and the Sun. And I guess, even though I talked about it for a bit, I didn't really give an answer, did I? So I don't have like the answer, but I think it does give a simplified model, a simplified way of understanding the motions of the heavens. So it's not necessarily that it gives you a greater ease of calculation. I think that, you know, the difficulty of crunching the numbers is not that much improved under the Copernican system compared to the Ptolemaic. At least that's what I've heard from historians. But it's conceptually a little better. And now this next bit is just my opinion. I haven't really heard it from any historians. But, you know, things like making sense of why Mars is much brighter at certain times of the year compared to certain other times of the year. Well, I mean, now we sort of know the answer, right? But I think it's, you know, maybe you'll take my side on this or maybe not. But if you think of the Copernican view, then it's like, okay, then the Earth is going on this inside track and we pass Mars every once in a while. And when we pass Mars, we're going to be really close to it. Mars is going to be brighter. Now, of course, you can get that in the Ptolemaic system, but you have to work harder to get it, I think. And the same thing with Venus and all that. So I think so historians, you know, have written whole treatises on this, and you know, you can certainly make the Ptolemaic system work. And if you add enough epicycles, you can make it work to any degree of accuracy you want. There's some neat videos about this on YouTube. Like, you know, if you just sort of add enough circles, like you could make Homer Simpson's face, but you need a lot of circles to do it. But you can do it. You know, you can make a planet trace out. So that's on YouTube somewhere. But things are conceptually simplified, I guess is the way I would put it. But what I just said about like the brightnesses of the planets, that's sort of my guess. I haven't really heard that from historians. But it does seem like certain things that you see from week to week in the sky just kind of make a bit more sense once you think of it from the heliocentric point of view. But yeah, I mean, it's a great question. It would be great to know what really sparked it.
Yes, I remember when I read about Copernicus the first time, and I heard he was from Poland, and you think of you know, 15th century Poland, and compare that image of your mind of that compared to what was going on in Italy and, let's say, Venice and Florence at the time, and you get the impression that Poland was like a backwater. Did you get that impression, like that Poland was a less developed place than Italy would have been? Okay, so that's a tricky question. The question is, did I get the impression that Poland was less developed than Italy? But of course, you're not asking about the 21st century, you're asking about back then. So that's a hard thing to assess from the point of view of the 21st century, I think. I mean, that's a great question, but I think it is, I'd have to be more of a historian. I'm just trying to think if I've read anything that would illuminate that at all. Well, I mean, that is, I think what you just said is sort of the reputation. I mean, that's kind of what you hear. Like, it was a bit surprising that this book did come from a place that far east, you know, that far off of the nexus of, you know, all of the great thinkers, allegedly. I mean, I'm sure this is what they told themselves or whatever, but you know, allegedly lived in a section of Europe that stretched from,
you know, maybe Naples, but Rome, whatever, certainly Rome, up to what, I don't know, Amsterdam, Paris, you know, something like that. If we look at it a century later, you could include London or Edinburgh, but it was a small little section of Europe. So Poland, I mean, and certainly, you know, Fromberg, I mean, it is, yeah, it's sort of outside of that zone. I mean, it's suspiciously far east. Yeah, and you know, I don't know what sparked, you know, Rheticus to go and check it out. I mean, he must have seen the short version, the commentary, I guess. But yeah, I mean, it's a good question. I guess I just can't say too much about it. But yeah, Poland certainly would not have had the reputation that, you know, Northern Italy had, or that you know, the Netherlands and France would have had, and Germany, of course. Yeah. Alrighty, yeah, thanks.
So thanks for having me. My name is Blake Nancarrow, and I wanted to talk about robots this evening. And oh, how'd that get in there? So I wanted to talk about robotic telescopes this evening, telescopes that you might use. And there's actually a system that you might try using that's completely free. So I wanted to share some information about this telescope system. This is the Burke-Gaffney Observatory that I'm talking about. It's in St. Mary's, or at St. Mary's University. And I first started using this in early 2016. I was inspired by Katrina. I saw her initially using it and saw her first image from that of a comet, which I'll show later. And I was very intrigued by that. I thought, wow, what a great sort of system. And I thought I would try it out. And early on, I envisioned sort of a project that I could undertake, which again, I'll talk about a bit later. So if you are interested in or are regularly doing observing or astrophotography here in Ontario, and you want more telescope time, interestingly, based on weather patterns, generally the clear weather that's here in Ontario will go over top of Nova Scotia a day later. So you can keep yourself quite busy, doing lots of imaging, maybe on back-to-back evenings and stuff like that. What's significant about the Burke-Gaffney Observatory, it is or was the world's first observatory, robotic observatory, that was accessible via social media. So initially, at the very early stages, it was envisioned that this would be used via Twitter and via Facebook. So if you have an account in one or both of those environments, then you're sort of good to go. You could use this system. Recently, I was just speaking with the director a couple of days ago, and there's actually a second system coming online, which RASC members could use. So I'll talk briefly about that later. So a bit of detail about the observatory, which is affectionately referred to as RALPH, the Burke-Gaffney Observatory, again based in Halifax, and the observatory itself has been around for a long time. It was originally set up in 1972, but there was a major upgrade done around 2013. If I remember correctly, a bunch of us were at NEAF, the Astronomical Forum down in New York State, and we bumped into Dave Lane, who is the director of the observatory. We bumped into him when he was telescope shopping. He was looking for a plane wave telescope, and he bought one while he was at NEAF. So that telescope that you see in that image, that CDK 24-inch telescope, that's the one he bought back in 2013. And in 2015, again, it became this first observatory accessible by social media. This is not unlike iTelescope or SLU. Who has an iTelescope account? Anybody? Anybody got an iTelescope account or a SLU account? I had a bunch of credits at SLU. I don't know if they're all expired now. So you may be familiar with a system like this in that you can issue commands or directives. You can indicate the target that you want the telescope to capture images on, and then retrieve those images later on. You can see the dome that the telescope is in, and the telescope itself on an equatorial mount, an old style equatorial mount. All of that is fully robotic, fully automated. And the nice thing about it, again, is that this system is free, and that was something that was attractive to me. Yeah, I'm a bit cheap, but it was also this idea that I could get my legs, try things before maybe wasting time on iTelescope, that I was interested in getting my legs, getting some experience, particularly with LRGB processing, image processing, before spending a lot of money on a formal type of system. So that was one of the things that sort of attracted me to this this telescope. There's a drone aerial view of the observatory. It's atop the 22-story residence building at the university. Obviously, it's used by the astronomy and physics department. Don't forget that this is out in the Maritimes. It's you're dealing with Atlantic time, so remember that 1 hour offset, and remember the normal sort of weather conditions out there. You're on the sea. You're dealing with that, but you're in a city. There's a bit of light pollution, but still it's elevated quite high, and that affords on good conditions some decent sort of imaging. There's the business end of the telescope. That's a fairly recent image, and if you look closely, you'll see that there are two actually CCD cameras on that, the red one and the blue one, not the little tiny bright red one. I believe that's the guide camera. So the sort of tomato colored one, that's an S-big. The blue one is the apogee, I believe. You can see there's filter wheels with those. Again, this is a 24-inch or 60 centimeter telescope. And again, there's multiple position filter wheels for each one of those cameras. So when you're imaging, you can indicate the filter that you want to use, whether it's a regular colored filter or a narrowband filter. That will indirectly then choose the camera. There are certain filters on certain cameras, so you don't sort of have complete control to mix and match things the way you want. You're going to be using a particular camera given on what you've selected. The mount, again, is an equatorial-based mount. I'm not sure the exact history of the mount. I've been trying to learn a bit of information about that. As I mentioned before, the dome is completely automated with the shutter and rotation controls. You don't have to worry about any of that. And the observatory has lots of instruments, weather instruments, so you can gauge weather conditions in advance. You can see what the weather conditions are at the time that the observatory is open. So there's a bunch of sensors there. And this is kind of a snapshot of how you would use the system. So again, if you have a Twitter account or a Facebook account, you're sort of good to go. And you can, I don't know if you can read the printing very clearly there, but you can see some of the interactions that a human has or a user has with the telescope. So commands are issued. I'll show you the format in a moment. And then the system will respond. So Twitter can be used to you can issue a tweet to the observatory, and when you have a well-formed command, it's going to respond to you and accept that particular request or command and take action, and then you'll get feedback on Twitter. Some of the messages are sent via the public Twitter feed. Some of the messages might come back to you by direct message. The Facebook page for the telescope is updated automatically. It's interesting how these robots were personifying them and making them seem like they're real and doing interactions. Obviously, this is clever computer programming on our Martian probes and by this telescope, but it does give you a sense of the status and what it's doing and what it's working on. You can monitor status also on the Facebook page. I keep an eye on that. I keep an eye on a web page as well to see status information, status updates. There's a whole priority system. Not surprisingly, the university students get first cut at this. They have the highest priority, and during school season, when school's in, telescope time may be limited. So that's something to bear in mind if you're using this. It's pretty easy to get up and running with it, though. You submit a request, you indicate why you would like to use this telescope, what your intention is, and then you get authorized, and you're good to go. You have to pick which mechanism or method you want to use for interacting with it. I can't remember if it was on a previous slide, but I'll mention it, that there is an issue, an outstanding issue right now with Facebook because of recent changes. You know, Facebook got in a lot of trouble a little while ago, and there's lots of security issues. So the Facebook interaction has been offline for a bit. If you want to use this, you want to try this, and you don't already have one, consider creating a Twitter account, and then you're ready to go. Facebook looks like it's offline for the time being. It is used for output purposes, but you can't send commands in yet. There's lots of information. There's a very good set of pages. You don't have to write all these down. I have the article on the website already, so you can look it up there, and I've shared all these links. But there's a good getting started page that shows all the basic information, so you know how to get up and running pretty easily. When you want to issue a directive or a command to make the telescope do something, you will form a tweet. You have to use a hashtag, so the pound symbol followed by a keyword, and then maybe specific options or elements after that. It's not programming, but it's there is a formal syntax that you need to use for those commands. Again, Facebook was used initially, but that's offline for the time being. But similarly, you would issue the appropriate hashtag command with options, and you were able to submit your requests and so on. So I have a sampler here of some of the commands that you might issue, like, what's the weather? So you issue hashtag weather, and the telescope will respond and tell you what the weather conditions are. So you can get a sense of it there. I monitor it by other means, but you can pointedly ask what the system thinks the weather conditions are and get a sense of whether it's going to open on that evening. When you want to image a particular object, you might want to look it up first to see what the formal designation is. Of course, we know that different catalogs might describe an object a different way. So you can use a lookup command to see what the appropriate reference is to find that object. And you can see I've noted a galaxy here, the PG C62-231 to look up that particular object. Typically, you're going to issue commands like that third line. That's the most complex form of that, which might be a little bit off-putting or intimidating. But you can issue a command in a fairly simple way, just by issuing the request and the object and stop right there. You don't have to add the exposure, the filter, the other details if you want. And the system will make a best guess. It'll use reasonable settings based on a profile and probably give you pretty good results. But you see, you can indicate the exposure time in seconds that you want to use. You can indicate the specific filter that you want to use. That example shows an O3, an oxygen, ionized oxygen filter. You can indicate a minimum altitude if you don't want the telescope to start capturing data too low. And you can add optional comments to it if you want. And another common command that you might, or option that you might use that I haven't shown there, is how many sub-exposures you want. So you can indicate, I want 10 images or 20 images to be collected at that exposure. If you've submitted a item, you can edit it later. You can change any of the settings or most of the settings for that. So you can see I've altered the minimum altitude here, and you can also delete the jobs later of your own volition if you decide it's sort of out of season or you're not interested anymore. All the commands, again, are documented on the website, so it's easy to look all those up. Now, I sort of proactively monitor weather. Lots of us do. So I've got a few references to the weather in Halifax, so I know what's going to happen. So obviously, I look at the clear sky chart for Halifax. I don't know if you use this system. Does anybody have CSAC alerts? Do you know what I'm talking about? The clear sky alarm clock. Anybody use that? So that's a great way, based on the clear sky chart data, that you can build a profile for a location so that when the conditions are good or optimum, you'll get an email. So I often get an email out of the blue that the weather is going to be good in Halifax, or maybe at the Carr Astronomical Observatory, and that's when I'll sort of perk up and look at the conditions and consider a trip, or I'll load in some targets to the BGO. Again, there's lots of weather instruments at the observatory, so I'll look at the sky quality meter information. I'll look at the satellite imagery and things like that. So I keep tabs on the weather, and a lot of this information is aggregated on a specific weather page at the BGO site. When I collect data, I often capture the charts to indicate or have a record of what the weather conditions were when I was imaging a particular topic, or target. So you can see I've captured a sky brightness chart and a sky temperature chart, which indicates roughly the cloud conditions. So a lot of times I'll keep that data as well as the imaging. When an image is captured, then I'll get an email message back indicating that it's in progress. And again, if I've missed some of the earlier communications about the weather conditions, I'll sort of perk up and start paying attention. And I usually monitor the Twitter feed, because the telescope is indicating what it's doing. I'm shooting an image for this person. Somebody requested the weather information. And a lot of this information is shown publicly. So I keep an eye on the Twitter feed, see what's going on. I might notice on some occasions that one of my jobs comes up is put at the top of the queue. Again, I'll keep looking at the weather and other things like that to see what's going on. The next day, I'll receive an email notification or a notification of some kind that an image has been captured, and then I'll head off to my completed observations page. So you can see that there's a table here, it's in reverse date order, and the top entries in the table are the most recent images captured. And there's a request ID number that was assigned when the job was requested. So I'll pull up that page and then I'll be able to see what's going on. So this is something that I do the morning after when I know some images were captured or I received a notification. And I'll dive into now the specific observing page for that. Now I capture images a particular way. I have an elevated status at the BGO, and I usually collect multiple filters at the same time. So I get all those images aggregated into a single zip file. So then I'll download that zip file and take it all apart, and I've got all the images in there. But if you request an image shot with a single filter, you get great feedback right away. You see when the image was captured. You get a small version, an automatically stretched image in JPEG format. So you see that at the bottom of the page right away. So you can see if it was a decent image, if there were any problems with cloud or moonlight, any gradients in the image, or maybe the telescope moved a bit for some reason. Occasionally there's tracking errors. So you can quickly assess your image. Again, if you've done a single filter shot of it. I don't see that image in my profiles because it's all been compressed into a zip file. If you're just wanting to take a few pretty pictures, you're good to go. You can grab that JPEG image, you can put it on your Facebook page, you can put it on your blog, you can do whatever you want with it. So you're sort of done. But if you want to do higher end stuff, if you want to do more detailed processing of the image, then you can download the official image format, the more scientific format, the FITS file, and that's at a higher resolution, at a higher quality, with all of the commensurate data that's inside a FITS file. So I typically download those FITS files. And again, I'm often shooting in multiple filters. So I've gathered red data, green data, blue data, and luminance. And then I'll put all that together myself. But I'll look at all those FITS files and then start to process that data. If you download that FITS file, you will very likely not be able to look at it right away. The software that's normally on your Windows or Macintosh computer or image apps that are on your smartphone or tablet will not open a FITS file. So it's a specialized format. It's used for scientific imaging. It's used for X-rays and things like that. You're going to have to do something. If nothing else, you're going to have to convert that image to a more common type of format. But you can download some free software that was made to process images that are gathered by the European Space Agency, by NASA, by the Southern Observatory. So you just have to download FITS Liberator. And you can do that for the Windows or the Mac platform. And then you're able to, again, if nothing else, look at the FITS image and then convert it into a useful format like a TIFF file. And your TIFF files you can probably display on your computer immediately, and certainly you can bring those into an image program, an image editor, to formally edit them like Photoshop or GIMP or whatever your preferred tool is. I do a lot of pre-processing in the images. You can see if you look at some of the controls on the right side of that software screen, you can see you can flip the image, you can turn on clipping display, so you can see if you're clipping in the whites or the highlights, you can see if you're clipping in the shadows or in the blacks. There's a histogram clearly below the image, and you can start to do stretching yourself. And there's a lot of ways that you can scale or stretch the image. There's a lot of different stretch types. That's a topic for another day, how FITS Liberator works. But the point is, if you're going to collect FITS data, you're going to want to maybe do a bit of stretching and then convert and save into a TIFF file. And then you can do what you want to do in your other programs. Now, interestingly, a short time ago, one of the newest, most powerful features added to BGO was the ability to do completely automated processing of the images. So if you're not inclined, if you don't know how to do image processing, and you've shot a single filter image, you shoot just a red image, and you get your JPEG of that, and then you shoot just a green image, get your JPEG of that, shoot your blue, then you can issue a process command, and it will put all those images together for you. And it does a reasonably good job. Again, using some of the appropriate options with the process command, you can get some decent results. So if you look in the title bar, it's very small text there, but that image of part of the Veil Nebula is a remotely processed image combining the luminance, the red, the green, the blue. And the user didn't do that. They let the system do it. And it's a good result. It's a nice result. There's a whole video tutorial online to talk about how to do that. Dave Lane walks you through how to use those commands. But it's interesting if you're in a hurry, if you're not inclined or not interested or don't have the software or reasonably powerful computer to do any of this yourself, then it'll take care of it. So that's nice. You can get color results right away. Some considerations when using the Burke-Gaffney Observatory. One could say you get what you pay for, right? So with a free system, there's lots of users that are using that system, but you always need to remember that you're not going to be terribly high in the totem pole unless you're a student there. So the students and postdocs and people doing research, they're getting very high priority in that system. And that queue is managed by the software, and everybody gets a certain weight and priority value and so on. There have been times where I've wondered what's going on at the observatory, and I've looked at the camera that's inside the observatory, and I've seen somebody with their eyeball up against the eyepiece. So there's public events that are going on there at any given moment. So sometimes the observatory will be offline. Usually there's a note or some sort of indication on some of the social media channels that the telescope's going to be busy or used for other purposes. Again, you got to think about the weather that's happening out there and the local light pollution and so on. This is maybe a good and a bad thing that there's an elevation constraint from the telescope that it can only go so low. When I started using this system, I hatched this idea to photograph all of the RASC finest NGC objects. And I was able to get all of them but two. Two of them are too low for the system. There's an object in Sculptor, and there's another one I can't remember. So the telescope can't get below or has constraints because of the walls and the edge of the dome and stuff like that. So, but then again, if you're imaging, usually you're going after things that are quite high in the sky too for best signal to noise, best quality. Obviously, you're using a long focal length telescope, and these cameras combined have a narrow field of view, so keep that in mind. And that means for some of my objects that I tried to image, some of these finest NGCs, they're big, right? So you can't fit the Veil Nebula. The Rosette Nebula would require a mosaic with at least 9 frames. But other objects, on the other hand, some of the planetary nebulae, tiny and just a few pixels across. So you're stuck with the way this system is configured, the way it works, and so on. But it's still, for me, been very enjoyable to use. I've learned a lot from it. And again, you're going to get these images back. What do you want to do with them? Do you want to do any processing on them? If you're not familiar with that, you're going to have to get up to speed on that. So lots of things to consider. Here's a quick gallery of some of the kinds of things that you can do and images that have been captured. This is the one that started it all for me. This is Katrina's image back in January, February 2016, where she imaged a comet. That's Comet C 2013 US-10, Catalina. And I was just blown away by it. I thought that's a great image, and it would be really fun to use this system to go after stuff like that. So that's one potential subject that you could go after, or any of the sort of interesting nearby active comets right now. This is one of the finest NGC images that I shot. That's the Splinter Galaxy, or NGC 5907. And this was one of my early attempts at putting together those LRGB images in color. And I did the assembly in Photoshop. And I was blown away. I still have much to learn about this, but I was really happy with that result. If you look at the bottom of the image, you can see there's a lot of red gradient. It's not a great image, but I really like the color in the center of the galaxy and the purpley kind of colors out in the arms. And I was just so happy. I was tickled when I got that. So this is the kind of thing that you can do, and somebody better than I would be able to yield even better results with that. I still struggle with gradients. The supernova SN 2017 EAW popped in May 2017, and I had shot the Fireworks Galaxy about 11 months before. So I dove back into my history to see if I had a discovery image of it was too far back. The supernova had just exploded there, but I went through the public log as well to see if anybody else had captured it, and nobody had. Nobody had shot this galaxy for a long time. But then I hatched an idea of following it. So about once a week for the next year, I imaged that galaxy. And I haven't done it yet, but I'm going to put together a movie that shows the supernova slowly fading out over the course of a year. I have to balance all those images. But that was a fun thing, seeing that supernova and watching it fade out slowly over time. You know me, I like double stars, so when the moon's out, I still use this system and I go and photograph double stars. This image I'm particularly happy with. Again, this is assembled, all the color channels assembled, and that one worked out really well. I really like the colors in that, no major gradients in that image. Not in the color channels anyway. So I shoot double stars with that to coax out maybe companions or members that I haven't been able to spot through the telescope, or where I had confusing notes. So I image it to try and figure out what I was writing about in my log. And you can image planets, some of the planets easily imaged with this. This was one taken by, I assume, one of the students, and that's one of the planets that Ed was talking about before, Uranus. And in that image, if you were to zoom into it, you can see Ariel, Oberon, Umbriel, and Titania. So 4 of the moons of Uranus, and 2 of them you can easily spot, I think. You can easily see 2 of them there at the 10 o'clock, 10:30 position, and at the 7 o'clock position. So you can see a couple of them there pretty easily. So these are the kinds of things that you can do. Some people shoot the moon as well, whatever. So why would you want to use this? Why did I want to use this system? I've alluded to some of this, but I had very little experience at the beginning of this with multi-channel color processing and collecting data from a CCD black and white camera and then trying to assemble that to produce full color images. So I thought, what a great way to learn how to do this at no cost and easy, in the sense that I didn't have to set up a telescope and go through all the stuff and figure out all the cabling and get all the software. Somebody else was taking care of that. That's one of the attractions to a robotic telescope, is that there's a technician that's taking care of all the hardware. And you don't have to worry about that. You just collect your data. And on iTelescope and SLU, you pay your fees and you collect your data. But I wanted to learn how to do this without an outlay, so that if I decide, okay, I really like this, I want to do this, I want to do it front to back, the whole process, including setting up the hardware, that at least one part of the job I'll have experience with. I had a general notion of using a robotic telescope and what might be involved, but I learned a lot actually from this. Even though it's fairly simplistic commands that we can issue and use with the telescope, it helped me a lot in terms of figuring out what to use, what's the best filter to use, the impact of the filter in terms of exposure time, So again, a lot of learning there, and also the aspect of planning. These objects with low surface brightness, I better not put these in the queue when it's a full moon. I'll save those for later. Let's empty the queue. I'll load it with double stars. We're going into a full moon phase. So it's helped me a lot with respect to planning targets and the best type of target and things like that. It's been a lot of fun. And I didn't set out to do this, but as I mentioned, when I've been visually at the telescope looking at some double stars and can't figure out what's going on or couldn't see a super faint companion, I'll image it and draw out fake companions or try to see all the members in a complex multi-star system. So that's been good. That's been fun. Why would you want to do this? Maybe you just want to do some easy astronomy at home and not break a sweat, and armchair astronomy. Again, remote telescopes are very appealing in that respect. But it's also it's a fun system. You can do your own learning with it, and again, it might be if you're not busy enough, it's something that you can do in other evenings. When it's clear here, you're going to be outside at your telescope or imaging here, and then a day later, you can collect data from Halifax. In general, the prevailing weather patterns are the clear weather in Ontario is going to be in Halifax a day later. So in the summertime, you can be quite busy. You get no sleep at all because you're capturing data every night or doing work every night, and then the next morning you're trying to process some images. There's the whole aspect too of discovery here. And I've had a few instances where I've thought, did I find something? I've seen an object in some of my images that may be moving or is not clearly a known star. A lot of them turned out to be false positives. They were cosmic ray hits and stuff like that. But this is another exciting thing about this, that you might be aimed at part of the sky and you might bump into a comet that nobody else has found. So learn the protocol about how you cross-reference and check something like that to see if it's real and legit, and get ready to write your astronomical telegram if necessary. Those are long URLs. Again, don't write those down. They're on the website. All that information is available, but you can learn a lot more about the system at the Astronomy and Physics page at St. Mary's University. There's a dedicated page for the observatory that collates all the information about how to use it and the weather information and so on. There's a Facebook page where a Facebook group page where people ask questions of each other and share their images and so on. And again, there's a link to the FITS Liberator software that was produced by NASA and the European Space Agency. Some late-breaking information. David Lane, who again is the director of the BGO at St. Mary's, he indicated that another observatory, kind of a twin, if you will, to this in terms of the capabilities and the software. It's obviously a different instrument. But the Abbey Ridge Observatory, that's his personal observatory, he's going to open that up to RASC members. So you could have an account there as well and use that instrument. And a big advantage there is it's very dark. He's 40 kilometers away, I think, from Halifax. So much darker skies with that instrument. And I think that's a C11. I don't think it's a C14, but it's a fairly big telescope. All of the software that's being used to manage the Twitter account and the Facebook responses and the account profiles and gather the data and process the images is in constant development. Dave is actively working on this and adding new features and adding new capabilities. Some interesting things are coming up soon or have just recently been released. He's allowing the ability to space out an observation. So if you want to shoot a variable star and it has a long period, it doesn't make sense maybe to shoot it every night. But maybe you want to get the system to capture it once a week or once every 2 weeks. So he's adding that capability that you can space out your observations. He's working on an Android app where you can directly submit requests to the system. And I'm very excited about the login portal that he's building, where users accessing the system this way will have more direct access to the telescope. So it's becoming more like iTelescope and SLU. If you have your smartphone and you have a QR code reader, you can scan that, and that'll take you directly to the webpage that I've put on the RASC Toronto Centre website. You can go to the RASC Toronto Centre website and just search for BGO, and you'll find the page that I've written there with all the links. A bit of shameless self-promotion. You can surf into my blog, and you can see all the images that I've captured over the 2 years. It's up around 400 now. I've submitted and received about 400 image requests. And a lot of those are multi-channel requests again. And then from there, if you want to jump off to my gallery, you'll see roughly 300 or 400 images that have been captured with the BGO. And many of those you'll see are, again, part of the finest NGCs. So lots of information at various places where you can learn more about this system. And that's all for me. Any questions? Any questions on the cloud? That would be apropos.
Comment, Dave Lane is watching the webcast.
Oh yeah, any corrections? I should ask Dave.
He's working on the Facebook issue.
Yeah, yeah.
He says that the ARO is up and available for our ASC members.
Mm-hmm. So ARO is the Abbey Ridge Observatory, that
ARO.
last one that other telescope image that I showed.
That's correct.
Yeah.
Yep. And yeah, that's pretty much it for now.
Okay. Good. No.
Any questions for him?
So Chris has a question back there.
I'm just curious about what is your turnaround time on requested images, and how many do you typically have in the queue at any given time?
So by turnaround, I think that you're asking about the time from when I submit the job into the queue to getting the image back, yes? That's a crapshoot. There's lots of factors for that. So if I was submitting jobs at the high water mark when the students are doing projects, it might be a couple of weeks, maybe 3 weeks before my image is processed or captured from the system. So the students, again, they get priority. In the summertime, it can be 1 day. I'll load in some jobs. Telescope's not busy. In fact, sometimes on the Twitter feed, I'll see a message that says, the queue is empty, I'm looking for requests. So I'll fire in a couple really quickly. And then you're downloading your images the next day. So there's lots and lots of factors, right? And of course, you load in some awesome targets, and it's cloudy in Nova Scotia for the next 3 weeks, or there's fires clouding out the conditions there. So you just don't know. Arguably it's like this with other systems too, like iTelescope and SLU, that you're gonna make a request and the telescope may not open because of bad conditions. So you don't know what's gonna happen. You're kind of rolling the dice a little bit with that. And you had another question. Sorry, I forgot the second part.
Well, now that I had the mic, I'll add a third. The question was, a maximum of how many images can you have?
The number of items that you can put in the queue, thank you for reminding me, is based on privilege. So I believe the default number is 3. 3 objects or 3 items in the queue. And the default user account gets 1 filter per image. If you're nice to Dave Lane, you can get elevated privileges. So I'm able to load 6 jobs into the queue, and each one of those jobs can be multiple filters associated with that camera. So sometimes I'll do LRGB, hydrogen alpha, and oxygen all in the one go. For that object. Still, there are caps with respect to the total exposure time, the exposure time for the individual image, and so on. So there's lots and lots of constraints here. But default is 3 items in the queue, and 1 filter per image.
What if it's cloudy and they can't meet your requirement, but they say, but user so-and-so took that image last night. Would you be interested in getting that one instead, or does that take the fun away?
So something to remember is that this entire system is publicly accessible. And in fact, all the images that are captured, even if you ask that the image not be shared, are publicly available. So any user, any person can crawl through the queue and see all the images captured. So there have been times where I've shot an image and then I notice somebody else is shooting the exact same thing. So you could argue, well, what's the point? Is mine any better? And it might be. There may have been a cloud that rolled by right at that occasion. So everybody's kind of blazing their own trail, and the system doesn't tell you if somebody else has shot the same target, but you might discover that as you're monitoring the Twitter feed or if you crawl through the logs. Yeah. Jeff, did you have some questions?
Thanks, Blake. How does the system...
Hold the mic up.
Thanks, Blake. How does this system handle calibration frames?
So there's a lot of things that are happening automatically. So say, for example, I ask for Messier 57, and I ask for LRGB filters. And I ask for, say, 30 seconds for each shot, and I ask for 10 subframes. What I get back are 4 images, the luminance, with the 10 subframes stacked. And I get the red channel, and it's the 10 red images stacked. You with me? So you get a composite or a combined image back from the system, and all the images are stacked up for you. The system is doing on-the-fly calibration. One of the images, you may have noticed the flats panel that was inside the observatory. It was on one of the walls, so the telescope at the end of the evening aims to the panel, shoot if necessary. It's doing some sort of assessment routine, but it will periodically shoot flats. It's doing dark image stuff. I'm assuming it's doing other types of image collection or data collection to remove bad signal or noise from images. In that respect, that's one of my frustrations with the system, where sometimes I've received my one particular image, say my luminance, and it's not good. That there's clearly misalignment in some of the images. If I was doing it myself with my own rig, I'd be looking at all the subframes and go, hey, that middle one's really bad, I'm going to ditch that. Now, the automated software is trying to assess those images, but sometimes the algorithms don't work. So a bad image a bad subframe might spoil the whole deck. And that might be a little bit off-putting. When it first happened, I went, well, that's just great. Now what do I do? And then I realized, well, you just load it up again. So I've just repeated observations where the data quality wasn't very good. If you were using iTelescope, you'll be able to pick. You're going to get all the subframes, and you're going to be calibrating them and stacking them and so on. So that's a big difference with BGO, is that you get that combined image back, and it may not be great quality for what you want, but it's easy peasy. And if it's really bad, you just do it again. You just resubmit the past email and do it again. On occasions where there's been a very particular problem, Dave's been able to go in and extract a particular subframe to figure out what's going on. We found some cosmic ray hits in one where I thought it was a moving object. So he has that access, but that's not accessible to regular users. So I'm getting the hook. Thanks for your time.
Thank you very much, Blake. All right. Okay.
Ready to go? Okay, so announcements for this meeting. Our next meeting is in 2 weeks, and there's been a change in the speaker for that one for a number of reasons, but our speaker that night will be Chris Gaynor, who's the president of the Society. He's in town that week, and so he's agreed to come here and give a talk on the history of the Hubble Space Telescope. So that'll be in 2 weeks' time. Our next Recreational Astronomy Night meeting is on the 7th of November. There's a few little gaps in the program. We do know that Dennis Gray is going to be speaking on digital occultation camera. Sky This Month will be presented, but we're not quite sure who's going to be doing it. And there is one open slot for that evening as well. So if you do have a project you'd like to talk about, please contact Paul about doing that presentation at that night. Okay, next solar observing session is on the 27th of this month from 10 till noon. It's the usual way. We'll have go or no go from Sean Lee, either Friday night before or very early the next morning. And again, that can be a lot of fun if the sun is out. Other observing parties, we did have a successful program last night. I think that was the dark sky, was it? Yeah, so the next dark sky one is on the first clear night of the week of the 5th of November. Our next city star party is the first clear night next week, Monday through Thursday, the 15th to the 18th at Bayview Village Park. Okay, we do have another outreach event at the Science Center this coming Saturday night, and this is to mark World Space Week here at the Science Center. This is the last of our programs here at the Science Center for the evening star parties for the year, and this one will be running from about 6:30 until 10:30 on Saturday night. The usual thing, we'll be needing some telescopes out on the telescape. I believe the booth is going to be also set up in the usual spot. So unfortunately, the weather doesn't look particularly good for this weekend, but if it does go ahead, let's hope that we can do something. But it's going to be cold, unlike today. Okay, another outreach event going on next week on the first clear night is a program being run at the York University Observatory, and this is for the Orionid Meteor Shower. And again, there is some go, no-go information being put out on the York Observatory's social media. I just put up the Twitter feed address, but they're also running on Facebook and a few other things too. So again, that's another opportunity to take a look at things. The CAO has a work party going on the weekend of the 20th of October. I'm not sure if we have all of the slots taken on that. Tony, do you know? Yeah, there's still a few slots open for volunteers if you'd like to help out with that, and certainly you know, it can be a lot of fun for that weekend. So again, that's something to possibly talk with Tony about later on. Okay, tomorrow night we do have another outreach event happening in town, and this is the Massey Talk at the Isabel Bader Theatre in Victoria College at the University of Toronto. Dr. Victoria Caspi is going to be talking about solving the mystery of fast radio bursts. This one, though, is not a free program. It's $20 general admission unless you have a valid student ID, in which case you get in free. But this is, again, one of the other events going on in the city. Just a reminder that the CAO is still available for you if you'd like to use it. Ed obviously has taken advantage over the last little while, and again, it's available even without a supervisor on the site. The only restriction is that you do not get to use the observatory telescopes there, but there's plenty of instruments available, and you can bring your own up as well. So again, don't forget that you can book that online through the website. All three of our telescope loan program managers are here tonight, so again, we have lots of instruments available, and again, if you want to try before you buy, this is the opportunity. And I see that Mark is turning something over even as I speak. Okay, one of the things this week, we're almost at the wind-up of our summer educational programs. I thought I'd just like to acknowledge that there's a lot of people involved with volunteer activity for the center. This is just a short list of the various programs that go on throughout the year, and particularly during the warm weather months. And you know, there's a lot of people who are involved here. I've just put the names of the people who actually coordinate these events. But again, we couldn't do a lot of things that we do without your help. And Peter Richards was just saying to me this evening that one of the things he's noticed is that a lot of our longtime volunteers are starting to get a little bit tired, and that's not unexpected. We do need new volunteers coming forward from time to time. We'd like volunteers who have been in certain programs for a long time to maybe try something new and just get renewed a little bit. And so, again, we have to encourage everybody to try and help out as best you can, because we couldn't do all of this without you. So thank you very much for those of you who have been volunteering. Again, it's very much appreciated. Okay, calendars are available this evening for sale. We've got a box up here, so if you'd like them, they're $15 each, and I think we've got a fair number left, so please come forward and buy. All right, meeting after the meeting will be at the Granite Brew Pub. Hopefully see a few of you there after the meeting, and again, we'll see you in a couple of weeks' time for the next meeting. Good night, all.